Welcome to This Explainer. Today, we're diving into a genuinely fascinating chapter from an early childhood textbook that honestly completely reimagines how we teach numbers. We're going to see exactly how early math transforms from, a dry set of abstract rules into this captivating series of magical games and visual puzzles. So if you've ever wondered how to make foundational math feel like pure play rather than a chore, well, you are absolutely in the right place. Let's get right into it. We're kicking things off with a wonderful character named NANI. She introduces math to two kids, Chirag and Nandini, not as some boring worksheet, but as an engaging magic trick. She uses little everyday items like hidden seeds and marbles. She literally just invites them to the table for a game, covers some items with a handkerchief, and claims she has this magical ability to know exactly what's hidden underneath. It's brilliant. So Nani Ma playfully challenges the kids to guess the number of items hidden under her handkerchief, which instantly hooks their attention, right? I mean, she's sparking their curiosity before a single equation is ever written down. The children aren't thinking about math at all. They're trying to solve a mystery. And of course, the text asks the young reader the exact same question. Can you tell what the trick is? Okay, now check out the data we're looking at here. It brilliantly illustrates how figuring out the hidden seeds is actually just a cleverly disguised exercise in mental math. Think about it. If you know you have a total of 15 seeds, but you only see 12 on the table, you've got to use mental deduction to figure out that 3 are hidden. Total is 17, and 10 are visible. Boom, 7 must be hidden. It's an incredibly effective way to build fluency. The kids are practicing missing add-in problems, which, by the way, is a notoriously tricky concept for early learners, but they're doing it with the eagerness of a detective solving a case. Section 1, Gamifying the numbers, turning equations into play. Let's see how we level up from a gentle magic trick into some friendly competition. The text introduces this fantastic card game that requires literally nothing but a simple set of cards numbered 1 through 10. The rules? Super straightforward. You shuffle, spread them face down, and take turns flipping one card over. The whole goal is to look at the card you just flipped, scan the cards already face up on the table, and find 3 that make a valid addition or subtraction equation. If you spot it, you keep the cards. It forces kids to rapidly test all these different arithmetic combinations in their heads on the fly. What's really fascinating here is how creating an equation is framed as the ultimate winning move. Look at Nandini. She sees a 2, flips a 4, and spots a 6. In a split second, her brain synthesizes those discrete digits into a mathematical relationship. 2 plus 4 equals 6. Because it's framed as a game, the repetition you need to actually master math facts, it doesn't feel tedious at all. It just feels like strategy. Moving right along to Section 2, Jumping on Number Lines, Visualizing Math in Motion. So, transitioning from tabletop games to physical tools, meet our visual helpers for this section, the grasshopper and the frog. The text uses these little guys to help kids visualize skip counting on a number line. The grasshopper is known for jumping backward by tens, and the frog, well, he jumps forward by tens. By associating the direction and the size of the jump with a specific animal, the whole abstract concept of adding or subtracting 10 suddenly becomes this highly visual, animated action in the child's mind. Now, take a look at the core pedagogical takeaway highlighted here in the teacher's note. It's absolutely crucial. It says we should be encouraging students to find their own flexible strategies rather than just forcing them to memorize rigid formulas. The book emphasizes that a number line can start from any number, and students can work with open number lines. It's not about forcing one right method. It's about giving them the freedom to visualize the problem however it makes sense to their own unique brain. Let's look at how this plays out in practice. Nandini is at the number 23, and she rolls an 11 on the dice. By visualizing leaps of 10 and steps of 1, jumping between numbers like 23 and 34 becomes deeply intuitive. She could take a massive frog leap of 10 to land on 33, and then take one small step to 34. Or, actually, she could take the step of 1 first to hit 24, and then leap by 10 to 34. Both are completely correct. This builds incredible number sense, showing kids that numbers can be deconstructed and put back together however they want. Which brings us to Section 3, Real-World Math Problems, Vedas, Plants, and Estimation. Now, we take these visual tools and apply them to the real world, because ultimately, math is a tool for navigating life, right? The textbook provides these wonderful, culturally grounded word problems. We have Rama, who sold 39 vadas in the school canteen one day and 12 more the next. Or Gehu, who brought 56 plants for a terrace garden, but after a few dried up, she only had 29 left. By wrapping addition and subtraction in relatable stories like these, the math becomes tangible. Kids aren't just subtracting abstract numbers, they are literally counting surviving plants in their heads. Next, the chapter throws in a really powerful estimation exercise. It challenges students to quickly sort complex equations into two buckets, more than 100 or less than 100. They get hit with problems like 134 minus 56 or 150 minus 49. And the catch is, they have to categorize them without actually doing the exact calculation first. And this is where it gets really smart. The crucial point here is teaching students to use benchmarks, proving that logical reasoning is just as important as exact computation. Look at the logic. A child knows instantly that 150 minus 50 is exactly 100, right? Therefore, if you subtract a slightly smaller number, like 49, the result simply must be slightly larger than 100. That is high-level critical thinking. It trains the brain to step back, look at the big picture, and understand how numbers relate to each other, instead of just blindly plugging away at a subtraction algorithm. Section 4, the magic square mystery, finding patterns in the grid. For our final act, we're returning to the concept of math as magic with this incredibly satisfying puzzle. This is the magic square. It uses the numbers 1 through 9 placed into a 3x3 grid. And the magic part? Well, it's an arrangement where every horizontal line, every vertical line, and even both diagonal lines add up to the exact same sum. Just take a second and look at it. 2 plus 7 plus 6 is 15. 9 plus 5 plus 1? 15. The diagonal, 2 plus 5 plus 8? Yep, also 15. It's literally a beautiful display of numerical symmetry. To help the students unlock this, the textbook actually provides a really catchy poem to guide them, telling them to add from left to right, top to bottom, and diagonally. And by following the poem, they aren't just handed the answer. Instead, it allows them to discover the hidden symmetry of the number 15 completely on their own. The joy of discovery is baked right into the exercise. Which brings everything full circle. It reminds us that math isn't just a boring list of rules to memorize. It's a fascinating puzzle just waiting to be explored. By starting with Enigma's hidden seeds and ending with the elegant symmetry of a magic square, this chapter proves that with the right pedagogy, numbers truly can feel magical. The final challenge leaves kids building their own magic squares by filling in blanks on partially completed grids, a brilliant test of their newly honed mental math skills. So, I'll leave you with this thought. Having seen these methods, how might you build a little bit of this magic into the way you think about or maybe even teach the numbers in your own life?